All right, so we're going to start with another type of plot. We've talked about histogram, stem, and leaves, and cumulative frequency graphs. And you're probably sick of these by now, but this is another one. And actually, on the IB exam in 2018, this showed up, or something based on this. Talk about an outlier, and we get it from here. So when we look at a box and whisker plot, it's just basically 5 numbers. The minimum value and the maximum value, you can probably decipher what those means. They are the smallest number, the biggest number. But these are probably new to you. Q1 is the first quartile, and the first quartile is just 25% of the data being less than that number. The median is the middle number. That's not new, but it's 50% of the data, right? It's less than that. And then Q3 is the next 25%. So 75% or less and 25% are above. So it's the third quartile, quartile meaning 4. So we have 5 things that we need to find in order to draw a box and whisker plot. We need the minimum value, we need Q1 and Q3, which is what we draw the box around. And then the line, we need the median, and then we need the maximum value. So this collectively is called a 5-number summary. You're going to see that sometimes. And all it means is find these 5 numbers. That's what it is. So to do that, and again, you guys can pause the video if you want to write this down or want to take this in or read it. I'm happy for you to do that. I'm going through it quickly. But these are the 5 numbers we need. This is how we're going to get them. So we're going to take a set of numbers. We're going to order from least to greatest, find the median. Based on that median, we're going to take the lower half, find the median of those numbers. And then we're going to find the median of the upper half. That's Q3. Max and min values, you don't really need to find them. Once you've ordered the data, they're right there. And then we plot the points. And away we go. So here is a set of numbers. We're going to start out by just ordering them. So the first thing I want to do is go, okay, there's a 1, and then there's a 2, and then there's 3 3s. So I'm going to go 3, 3, 3. Then there are 2 4s. So 4, 4. Then there are 1, 2, 3, 4 5s. Then there is a 6. Then there are 2 7s. Then there is an 8 and then a 9. And let's just make sure I got them all. So I got a 1, I got a 2, I got 3 3s. It's important too to do this to make sure you got all the data, because it's easy. I've done it lots to just forget numbers once you've done this. So it's important to just check. So 1, 2, 3, 4, 5 5s. We have a 6. We have 2 7s. We have an 8 and a 9. So there's our ordered set of data. So then we got to construct the 5-number summary. So we know the minimum is 1. We know the maximum is 9. That's easy. The median, we got to count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if there's 16 numbers, then we got to go half of that. So 8. 1, 2, 3, 4, 5, 6, 7, 8. So we want 8 below, 8 above. So the median is right there. So the median is 5.5. Right? Because it's the number that's in between 5 and 5. Sorry, it's not 5.5, it's 5, because it's in between 5 and 5. Generally, it's in between 2 numbers and it's halfway between, but it's not because they're both 5. Then we need the median down here. So there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we go to the 4th number. And there's Q1. Q1 is between 3 and 3, which means Q1 is 3. And then Q3 is 1, 2, 3, 4. It's right in here. And here's an example of what I was talking about, where there's 6 and then 7. So you take halfway in between. You say the Q3 is 6.5. So what we do then, once we have all our numbers, is we just draw a number line. So, whoa, let me do this a little bit cheating, but we'll just put in a number line the way that I want it to look, because I don't want it to be, just a second here, what's going on, my computer's freaking out. Get rid of that. Okay, we're all back to normal, I think. So let's try this. There we go. So there's our number line. We're going to go from 1 to 9. You can count them out or not. It's up to you Like you can actually write them all down. I'm going to say there's 1, 3, 4, 5, 6, 7, 8, 9. So there's 9. And you can put little arrows on the end if you want. There's 1. So Q, the minimum is 1. Q1 is 3. So there's Q1. There's the median. That's 5. Q3 is 6.5. So there's 6.5. And then there's our maximum. So what we do is we're going to draw a box around these two. I'm just new to this pen, so that is a really bad box. Then we're going to draw the median down here. Then we're going to draw out to our maximum. And we're going to draw out here to our minimum. And again, I apologize for the non-box-like shape of that box, but that is the idea. Maybe I can recognize it as a shape, and it'll... No, it didn't even recognize my shape. That's how bad it is. But there you go. So that is a box and whisker plot. Now, look at another example. You can actually read stuff off of this box and whisker plot. So here's an example of test scores. The lowest is 25. The first quartile is 55. Median 70. Third quartile is 85. Max score is 98. All right, so it says, what's the highest mark? Highest mark is the max number. It's 98. Second question says, what's the lowest mark? So that's the minimum. It's 25. Half the class scored greater than or equal to what? That's the median, so that's 70. Top 25% scored at least what? So that's your top 25% started at 85. The middle half of the class, that's what's called your interquartile range. So 50% is in this box. So they score between 55 and 85. The range of the data set is just the lowest number taken off of the highest number. So the range is from 98 minus 25, which is 73. And you can write that in if you want to know where that came from. You're just taking the max and subtracting the min. And then the interquartile range is 30. Where am I getting that from? I'm taking Q3 and I'm subtracting Q1. So I'm taking 85 and subtracting 55. If you want to write that in over top or kind of see where I'm getting that number from. The max here was 98 minus 25. So that's how it works. That's a box and whisker plot. What's helpful about box and whisker plots is you can actually find what is called an outlier. So an outlier is defined as a value that's either 1.5 times the interquartile range above Q3 or 1.5 interquartile range below Q1. So in our last example, this one that we just talked about here, our interquartile range was 30. So if I wanted to know what's an outlier, I would take 1.5 times 30 and I would get 45. So anything that's 45 above Q3 or 45 below Q1 is an outlier. So then I just say, okay, well, Q1 is 55 and Q3 is 85. Again, that's from the last question. So if we look back here, right, we found out there's Q1, 55, Q3, 85. So if I take 45 off of those, off of this one, anything that's 10 or lower is an outlier. And then anything that's higher than 130 is also an outlier. Now, sometimes these numbers don't even make sense. You can't, if the score is out of 100, for example, it was a box plot out of 100, you can't have an upper level outlier. You can't get 130. But you could get a 10, and that would mean you were an outlier. It's an anomaly. It doesn't fit the pattern of the data. So that's what an outlier is. And again, like I told you, there was a question on the 2018 IB exam that asked you if something was an outlier. So just important to know, it's not a hard thing to remember, but it's not in a formula booklet, so it's important to understand. All right, so that's what an outlier is. So here's just an example for you to try. I'll give you a couple minutes. Just pause the video and just try it. There's the bell. Perfect timing. Okay, so the interquartile range and all those things, you have to order the data first, and then you have to go through it. I will go through that actually in another video because I'm going to run out of time on this one. So this is the first of two, we'll say, and we'll try to get through that box and whisker plot again.